Look at lucky you. You get to have an extra practice test and a video for this one. So this first one's saying the function of f plus the function of g. Remember, this has nothing to do with it. It just tells you what your input is, saying that you can plug things into the x, just like that. This is not multiplying. It's just telling your input. My function of f is x squared minus 3x minus 18 plus my function of g. Because adding it does not change anything, I don't have to put parentheses around that. So these two are like terms, and these two are like terms. So my overall answer, if I'm writing it in standard form, which I should, this is a negative 3 plus 1, which would give me a negative 2x. Negative 18 plus 3 would give me a negative 15. So this would be my final answer. Second one, it says the function of g. Notice how this first term, it doesn't matter, this first equation. I'm not putting parentheses. I'm subtracting this whole equation now. And because I'm subtracting this whole equation, I'm putting parentheses on that. Subtraction means the opposite. So I can rewrite this by distributing my negative to all three terms. So this is saying the opposite of x squared, the opposite of negative 3, which would be a positive 3x, the opposite of negative 18, which would be a positive 18. So now I can combine like terms. So this becomes a negative x squared because of that negative right there. X plus 3 would give me a 4x because there's like a 1 there. And 3 plus 18 would give me 21. Final answer. That's a 1. Kind of hard to see. Multiplying. So I have my function of f times my function of g. I like to do the box method just so that I keep it nice and organized. So this means that every term here, so x and 3, has to get multiplied by every term in my other equation. So I have x squared times x would give me x cubed, because I'm multiplying here. X times x squared is x cubed. X squared times 3 would give me 3x squared. Negative 3 times, there's like a 1 here, times 1 would give me negative 3. Then x times x would give me x squared. 3 times negative 3 is negative 9, and then this would just give me 1x. 1 times negative 18 is negative 18. I have 1x. And negative 18 times 3 is negative 54. Now these two are like terms, and so are these two. So I have my x cubed first. So I could put adding in between all of these. I could write all of these terms out and have a big one adding, just like how this was if you want to do that. Negative 3x squared plus 3x squared. So I have x cubed plus 3x squared minus 3x squared. That's where I'm at right now. These two combined together is just 0. They cancel each other out. Then I have a minus 9x, a minus 18x. These two are like terms. I can combine those together, and I get a negative 27x, and then I have a negative 54. So if you would prefer, once you multiply, write out each one individually, and then that might help you notice how you can simplify. Dividing. Here we have x plus 3 on top, divided by x squared minus 3x minus 18. I have to factor this. Numbers that multiply to get 18, that add together to get negative 3. One of these have to be negative. Because I'm adding to get a negative, I'm putting a negative with the larger number. So nope, does not add to get negative 3. Nope. Yep, this one does. So I can rewrite this. My x plus 3 does not change on top. On bottom, I can split up that x squared. Remember, if I split up that x squared, there's an x in each, and then one parenthesis has to have a plus 3. The other one has to have a minus 6. Now, because of this multiplying, these two cancel. And I guarantee one of you will do this, and I hope you don't. If you have that as an answer, that is incorrect. This is on the bottom of the fraction. So this would be 1 over that. Saying something is 1 over 50 is a lot different than saying 50. Next. So I'm looking, I can rewrite this equation as h, the function of f. So if you want to, you should rewrite these. So now my function of h, again, I've said this in class multiple times. I always write down the equations in which I'm dealing with. This is the function on the inside. This gets my big box, and it goes inside that little box. So I can replace my function of f with what that's equal to. So I have function of h, and then inside that function of h is my function of f, which is x squared plus 5. So if I look at my function of h right here, this is 3 times x minus 7. I'm replacing this whole thing, x squared plus 5. So if I distribute this 3, I get 3x squared plus 15 minus 7, which is equal to 3x squared. 15 minus 7 would give me 5, 6, 7, 8. Final answer for question 5. Here, now I'm starting with a number, so I'm going to focus on that number first. Remember, this is saying that x is equal to negative 3 in my function of h. So this is 3 times negative 3 minus 7. So negative 9 minus 7 is going to give me a negative 16. Negative 9 right here minus 7. So now this whole thing is equal to negative 16. So now I'm changing this with negative 16. If I look at my function of f, it says x squared plus 5. Now I plug negative 16 into that. I don't know what negative 16 squared is. But I do know that when I plug this into my calculator, I make sure to have that in parentheses. My answer is 261. One answer. If you box in both of those two numbers for your final answer, I would mark that wrong. You have one answer there. Start with an x, I should end with an x. Again, here's my function of h, here's my function of g. I write out both equations. Whatever on the inside gets the big box. Whatever on the outside gets the little box. So in my function of h, I'm replacing this whole thing with what my function of g is equal to. Now this is 3 times x minus 7. This whole thing goes inside that location. So if x squared minus 8x plus 7, I distribute that to all three terms. And plus 21. And I still have that minus 7 at the end. Now I can combine those like terms, and I get 3x squared minus 24x plus 14. Bing, bada, boom. Next. Pew. I can solve. So one thing when you're solving, you want to make sure to get your root by itself or your fraction exponent by itself. Here, first thing I want to do is add over this 5. So plus 5. Now I have the square root of 2x minus 4 is equal to 2. So to undo a root, the opposite of a root is squaring something. So whatever I do to one side, I have to do to the other. So now this becomes these two cancel. 2x minus 4 is equal to 4. So to get rid of the subtraction, the opposite of a subtraction would be adding. So now I have 2x is equal to 8, because 4 plus 4 is 8. Divide by 2, divide by 2. X is equal to 4. Question number 9. First, I'm going to look at this right here. Okay, that's odd. So I'm going to write one answer over here. I'm going to have one answer. I first have to get this by itself. I can't do anything until I have that by itself. So I'm going to subtract my 5 first. So I still have this x minus 9 to the 3/5 is equal to 27. So I need to get rid of that power exponent. So I'm going to raise this side to the 5/3. If you still want to change this to a cubic or to a 5th root, you sure can and solve it that way. Now, when you're typing this into your calculator, be careful. This is 27 raised to, I would put this in parentheses, 5/3. That right there, depending on your calculator, it could change if you don't have those parentheses. You should get 243. So we already said that we have one answer. So now we just have the 243. So I add 9 to both sides. I get x is equal to 252. Here I'm going to check first. So looking at that 4, that's even. Even has 2 answers. So again, first I have to get rid or get that by itself. So I'm going to subtract my 6. So I have 2 times x plus 24. The 4/3 is equal to 162. I have to get rid of that multiplication. So divide on both sides by 2. If x plus 24 to the 4/3 thirds is equal to 81. Now I can raise both sides to the 3/4 power. So again, when I'm plugging this into my calculator, 81 raised to the 3/4 power is equal to 27. And because I have two answers here, I have plus or minus 27. I would highly suggest to write this out. Otherwise, a lot of times people make simple mistakes. Look at how the answer changes, not the x plus 24. For both of them, I subtract 24. And when I do 27 minus 24, I get 3. And when I do negative 27 minus 24, I get negative 51. For my graphing, you don't have to state the transformation. If you want to, though, I see that this is going to stretch, and this will move it to the right, 5. So to refresh your how to put in your calculator, go to y equals, clear out anything you have there. I type in my 3. I need to go second x squared right there to get my root. Type in my x right next to my alpha, and then minus 5. So first I'm going to go to my table. I want to make sure to plot the first point. You can move up and down here. Notice that. So my first point is 5, 0, and I'm going to just plot these points on my graph. Phew. I have 5, 1, 2, 3, 4, 5, 0. The next point would be 6, 3, 1, 2, 3. Next point I have 9, 6, 3, 4, 5, 6. I can't go any further. I'm going to push graph just so I kind of know where it looks like. It should look like this, and you should have a curve with an arrow at the end. Now, this is the point I want to focus on. This point is 5, 0. My domain is x, my range is y. So when I focus on that point, my domain is x, my range is y. If I'm standing on this point and I'm focusing on my domain first, domain moves left and right, and I'm walking on the path of the graph, I'm moving to the right. When I'm moving to the right, x is getting larger. So this is greater than or equal to. Same thing if I'm starting at this point and I'm walking on this path. Now I'm focusing up and down. My graph is moving up, so y is getting larger, greater than or equal to. Next one, y equals. So first you plug in that negative. You have to make sure to push this negative key. So negative second x squared to get your root, x plus 2. Notice how I am arrowing over to do the plus 8. Notice how I had arrow over. You want to make sure that those two look the same. I go to my table. So look at, okay, so here's my first point without the error. So I have negative 2, positive 8. And then I have negative 1, 7. And then I have 2, 6. And I have 7, 3, 4, 5, 6, 7, 5. And if you push graph, just so if you're like, oh, what does this look like? Make sure you don't have a tail. You have an arrow there. I'm highlighting this point right here, which is negative 2, positive 8. This is my x. This is my y. So my x value, x, again, if I'm standing at this point, actually, I'm going to go for the transformation. The negative will flip it. This will move it to the left 2. And this will move it up 8. So standing at this point, moving on the path, it's moving to the right. If I'm going to the right, x is getting larger. So this is x is greater than or equal to my x value is negative 2. Range, I'm focusing on this point, following the path. The path is moving down now. So y is getting smaller. So if y is getting smaller, it's less than or equal to my y value here is 8. There. See, not so hard. Easy peasy, lemon squeezy. Have a piece of cheese. I don't get it. Okay, have a great, grand, wonderful day.